Alright. Now, when you go and you see these recordings, just remember I'm a math teacher and not a professional recording artist, so my recordings are terrible. If you have geometric shapes, they basically, when we talk about the relationships, there's three, and I'll put this one over here because it really doesn't matter. There's three relationships that come out of this. They're either congruent, they're similar, or there's no relationship. So let me zoom that in a little bit, make that a little bit better. So there's three things: congruent, similar, or there's no relationship between them. Now, congruent says that all corresponding sides and angles are congruent. And I like to say same size, same shape. And the symbol that we use for this is an equal sign with the little squiggly on top of it. This might work a little bit. Ooh, that's nicer. Much nicer. Now, for similar objects, for this, all angles are congruent. All sides are proportional. And I like to call this same shape, different size. So if we want to think about it in a different way. And the symbol that we're going to use here is we don't use the equal sign, we just use the squiggly. Which in Spanish, what's it's called, a tilde? Anybody remember? No? Alright, if there's no relationship, then, well, there's nothing going on here. So, if there's no relationship between them, that means they're not congruent, which means all corresponding sides and angles are not congruent to each other. One might be, but not all of them might be. You could have parts that are congruent, but not the whole thing. And when we talk about congruent, we're talking about, the key word is all. And if there's no relationship, then it's not all of the parts. Now, you've dealt with congruency, where you have shapes that are the exact same size. And they go, you kind of go from there. Now, similar shapes are a little bit different. And that's what we're going to talk about. But first off, this idea of kind of the difference between the two, the big thing for this whole thing to make it work is that you're going to come up with proportionality. Sides that are proportional. So let's take a look at some shapes. Here's an example of similar shapes. I'm going to take a square and then a bigger square. Say that's 4, 4, 4, 4. That's 10, 10, 10, and 10. Now, when you're talking about shapes like squares, your regular shapes, squares, equilateral triangles, all that stuff, they're always congruent, or they're not congruent, they're always similar, because for similarity, the first thing you look at angles. Are all the corresponding angles the same value? Yeah, all angles are 90 degrees. So we know that's going to be the case. So we know that, first off, that all the angles are 90 degrees. Now, here's the sides are always proportional. So if we take, and the nice thing about this is, since all sides are 4 here and all sides are 10 here, what we're going to set up is a proportion. And for example, if we're going to use this side, we're going to use this side. And we're going to get 4 over 10. Then if we take these two sides right here, here's where our proportion comes in. That side's 4. This side is 10. Now, is 4 over 10 equal to 4 over 10? Yeah. And we can even reduce it down. If we took 4 over 10 and we reduced it down, what would we get? 2 over 5. So 2 over 5. And this is actually called a scale factor. And in all of these cases, the similar shape is, if I took like 10 over, or if I took 10 and then I multiplied it by 2 over 5. So I took the bigger shape and I multiply it by a scale factor. Well, 10 times 2 is 20 over 5. Well, what's 20 divided by 5? 4. So that 10 comes from that side, that 4 comes from over here. Now, the thing is, this is how models are made. This is how you make, for example, you go out and you buy a model car, and you have to put the model car together. A lot of times they are like 1 to 16. Sometimes they say this, 1 to 16, 1:16, which means that it's actually 1 to 16. So if you had a model, say you had a model triangle like this, and that was 3, 4, 5. And I wanted to figure out the bigger triangle. Now this is not drawn to scale. What would I have to do to 3 to figure out what this side would be? Three times what? I think I hear it. 3 times 16. Well, what do I have to multiply the 4 by? $16. Now what would I have to multiply the 5 by? 16. Now this gets me to 48. This gets me to 64. And this gets me to 80. And this is kind of how a scale factor would work. If you had a car and they said every piece in that car, that model car, is 1/16th, or the scale factor is 1 to 16, which means it's basically a 16th the size of a real car. If something's an inch, then you multiply it by 16 and you get 16 inches. That would be how long the actual original piece would be. So when we're dealing with those scale factors and things like that, now if I know it's 1 to 16, if I had 48, I'd multiply it by 1 over 16, and that 48 over 16 would get me back to 3. And that would get me back to the side that is proportional or similar to the other side. So a lot of times what you're going to be asked to do, and especially on the work that we're going to be doing today, you're just going to be dealing with numbers. You're just going to be dealing with, all right, first off asking if these sheets are, or if these objects are proportional. If they're proportional, you just say yes or no. You have to, the biggest thing what you have to do is you have to check this. And we're going to go over some examples for that in a second here. But one last thing before we get to this is math likes their symbols. But first off, any questions on this type of an idea? Remember, we're just in the infancy stage of this. We're just building this up. Now, symbolically, if these two shapes are similar, we would say triangle ABC is similar to triangle DEF. This shape right here means is similar to. Now, when we get this, and this whole thing right here is what we'll call a similarity statement. What this tells us is angle A is congruent to which angle? It's like a congruency statement, sort of, as far as the angles go. Angle A is congruent to, remember, things go in order. So angle A is congruent to angle D. Angle B is congruent to which angle? Angle B and angle E. They're in the second position of the name, and the name means everything. So angle B is congruent to angle E, and angle C is congruent to which angle? Angle F. So that's the first thing you get, which is your congruent angles. The second thing you get is proportional sides. So take your first side, AB. And we're going to create the proportional side. What's the corresponding side of AB? If you look at the name AB are the first two letters, what are the first two letters of the second name? DE. So AB divided by DE. Now, since they're proportional, it should be the same type of scale factor for each one. Now, the next segment would be BC. Now, BC is the second two letters. What are the second two letters here? EF. Now, the third segment is AC. So we got A and C. Now, that's the first and the third letter. What are the first and the third letters here? DF. Now, I don't know numbers, but let's just say for fun, I said that's a 5, that's a 7, that's a 10, and I know this is a 15. Can we figure out what all the other values are? Absolutely, because from here, I could come up with AB over DE is equal to BC over EF. I could come up with AB over DE is equal to AC over DF. And I could come up with BC over EF is equal to AC over DF. So that's kind of what happens here. Now, do I know any of the values? Do I know AB? If I just take a look at this one first, do I know AB? All right, I know 5. AB is 5. Do I know DE? It's 15. Do I know BC? It's 7. And that's got to be over EF. Now, how do you solve a proportion? Well, yeah, you figured out the scale factor. But the proportion does this. Remember cross product? All right. Five times EF is equal to 15 times 7. Now, I'll just tell you this. Don't worry about multiplying 15 times 7 yet, because we want to keep things factored. Divide that by 5. Can 5 divide into 15? How many times? 3. So 5 divides into 15. Actually, let me use this one. And this is why I use highlighters instead of just crossing things out, because you can actually see what the numbers still are. So if you go back and there's a mistake, you can kind of see things, because if we just cross stuff out, we'd lose the numbers. So that's a 3. So 5s divide out, they just become a 1, so I get EF all by itself. And that's 3 times 7, which is 21. So 5 times what got me to 15? I know this answer is 21, but that's 7 times 3, isn't it? The nice thing about similarity is once you figure out what your scale factor is, now to get from this triangle to this triangle, I'm multiplying by what value? Multiplying by 3. So this guy should be 10 times what? Which is 30. And you could have figured that out using your proportions as well. But as soon as you know the scale factor, like I said, is the key to the entire problem. Once you get that going, you're good to go. Does that kind of make sense?